Hi, this is going to be the demo of the SLEP package that we developed here at ASU, and the SLEP.exe file is here. I'm going to click it, and this is a package which provides many routines for sparse learning. And if you look at this, we have fused lasso, and there's a lot of routines for alone regularize, for least squares, non-negative least squares loss, logistic loss, and we have the group lasso, multitask learning, multi-class learning, and a bunch of other methods related. And we have the MATLAB version, which is already there available in the internet, and that has a few other methods, and those methods are will be added to the SLEP package in future. And so it's developed in C, so it's quite fast. And so I'll now just show you how to execute with a real data set and get the results. So we have the Alzheimer's disease data set here. It's MRI-ADNL.mat. It's a MATLAB file. So I'll just go and show you what it has. So yeah, I've just loaded this MATLAB file, mri.adnl.mat, and if I check this, it has a lot of these are the data. So these data are into different groups. This is the first group, second, third, fourth, 5, and this is the label matrix. So this is for each patient, and if the patient has converted into Alzheimer's or not. So that's what this says. It's basically 1 minus 1 label vector. So we have the data here. So I've now split the data into 3 files, which is a.a_mri, which has all the data about all the test data, and this is the group information, which specifies how this matrix is split into groups, and this is the label matrix here. So what I'm going to do is I'm going to execute group lasso to get an answer for this thing. So I go here, execute group lasso with logistic loss, and we have a bunch of options here. So we can specify the starting point if we want, and we have the termination options like maximum iterations, tolerance, and the condition in which it terminates. So I'm just setting it for running it for maximum iterations. So we have the normalization, regularization methods, and the regularization, we can specify the alone regularization parameter here. So I'm going to specify it to be 0.5 to get more sparse solution. And we have the methods here, so we can experiment with the different methods here, and some of them converge early, some of them late. So here, instead of using random data, I'm going to use real data. So I'm just going to go here and add this a_mri file and add a vector here, and the label vector here. So it shows the dimensions here, and the group information will be added here. Yeah, so the group information. So I have the options, and I'm gonna just go execute it. So it says that it is run successfully. It just took 0.7 seconds, and the C value is here. So let's go here, take a look at the data. So it is run for 1000 iterations, so the F value will have all the values. It has gone through all the 1000 iterations. And let's have a look at the data here. So we see that yeah, so all these things show that most of the things are very close to 0, and some of them are maybe a bit higher than the others. So it's like these blue values show that it's it's a positive value, and it's quite high compared to the other values. And these light purple things that you see, those are negative values, and it's very close to 0. So all those white values are close to 0 basically. So you find some blue values here. So and then you find that this group entirely is 0. So these represent that it is 0. So this group entirely is going to be 0. Yeah. completely. Yeah, all these groups are 0. So just close this thing. Yeah, and you can even have a look at the data in the notepad or text pad, the generated data. So this shows that, yeah, it's quite like the first, yeah, I think the first group is non-zero and the rest are all zeros. So yeah, so we have all the other methods coming up into the future versions. So if you want more information, you can view the help here. Okay, I think that's it. Thank you.